Okay, this is also part of example 2, and we're going to do it 3 times. I'm going to show you how you could think of this 3 times, which are all pretty much the same, but it is a little different. What would I have to do, just looking at the column on the left here? What do I have to do first? Divide by 3, right? Don't multiply 3 times 2. Can't do that, right? One of them is raised to x power, the other one is not. You have to divide by 3. So that is 2 to the x equals 14. So we've isolated the exponential. Now we've got to take the log of both sides. Which log? Log base 2. Okay, this is what happens if you take log base 2, which is what the book does, okay? They say log base 2 of 2 to the x equals log base 2 of 14. Okay, what does the left-hand side simplify to? X, right? That's why we did it, so that we could simplify and just say that's x. Now, log base 2 of 14, if you have an 83, you can't do that. You have to use change of base formula. So you're going to say log of 14 divided by the log of 2, which you could put in the calculator, 3.807. Oops, 3.807. If you have an 84, you don't have that issue. I can see, let's say, every one of you, can't see your calculator. Do you have 84, 83? So you got the 83. If you have the 84, you could actually go to that log base function right there and just enter it in as log base 2 of 14. Remember, in the math menu, go all the way to the bottom, you see log base. Okay. Here's another way to think of it. So let's do it one more time. Of course, when I isolate, I get the same thing. 2 to the x equals 14. Now, if I didn't take the log base 2, let's say I'm just going to take log base 10 of both sides, then I would get this. Log base 10, and I'm not going to write the 10 because it's assumed, of 2 to the x equals log of 14. Okay. Now, by the power property, what can I do with that x? The exponent is x. What can I do with it, John? Put it in front, right? I can move this to the front. So now I've got x log 2 equals log 14. Okay, now I'm trying to solve for x, so I divide both sides by log 2, right? So x equals log 14 divided by log of 2. And it's the same thing as a change of base. You know, you don't really have to consider it like a change of base. The point is not that I have to use exactly the same base because that's how I can solve for x. The point is, if I take the log of any power, because of the power property, I'll be able to pull the variable to where I can solve for it. And in the end, it's fundamentally the same thing. And I could even have used natural logs, right? Because I got those in the calculator too. I could have, at this step here, right, I could have taken ln of 2 to the x equals ln of 14. So x ln of 2 equals ln of 14. So x equals ln of 14 divided by ln of 2. Which is what we know from change of base. It doesn't matter what the log, you can always change to another base by doing that. And in every case, you're going to get the same answer right there.